In this tutorial, you will learn the necessary steps involved to fabricate a custom abutment and posterior crown using InLab 3D software. For this process, you will need a stone model with a gingival mask prepared from a physical impression provided by the dentist. You will also need a titanium base kit and meso-zirconium oxide block manufactured by Sirona to create all necessary components of this restoration. Note that your titanium base kit is specific to the implant system being used by the dentist. Kits contain the titanium base, mounting screw, and scan body needed for scanning this case into InLab 3D. Meso blocks are sold separately and specifically designed to optimize the milling and seating process of custom abutments with your InLab MCXL system. Each block ensures accuracy by providing a precise, pre-drilled hole in the center of each block that will fit securely around each of our titanium base kits. The user need only ensure the proper size block and shade for the required meso block. Sirona offers implant kits that correspond with most implant systems from Nobel Biocare, Straumann, Biomet 3i, Astra, and Freodent. For a complete listing of implant systems, please visit www.sirona.com or ask your Patterson representative for more information. Start by opening your InLab 3D software and click the New button to start a new case. Enter new patient information in the dialog box and click OK to continue. You will now see the setup screen for your new case. Select your tooth to be restored from the odontogram. Also select Implant from the Restoration section, Bite Gingival Material Scan from the Bite Registration Technique menu, and Biogeneric in the Design Technique menu. Also note the Implant Selection drop-down menu. Select your tie-base kit type from this menu. Click OK to continue. Before we begin acquiring images for this case, we must first ensure that our model is ready for scanning. With your gingival mask removed, place the titanium base into your model and place the scan body from the kit so that it rests firmly on the base. It is important that you ensure proper fit of the scan cap onto the base. You will notice a notch in both the scan cap and the titanium base that will help you ensure proper placement. With the model prepared for scanning, place it in the model holder of your INEOS Blue Scanner. Now let's return to our InLab 3D software. You are now in the Image Acquisition screen. Click Preparation to indicate that this will be the first scanned images for this case. It is now necessary to select your acquisition technique from your choice of the options. We will select the free scan option for this case. This selection will activate the INEOS Blue camera. Scan your model moving from the distal neighbor of your tooth to be restored to its mesial neighbor. With the preparation scan complete, we will now scan our gingival mask. Remove your scan cap and tie base prior to placing your gingival mask over the preparation. Press the Gingiva button to begin acquisition of an image for this feature. With this image captured, place your bite registration on the model and click the Antagonist button to begin image acquisition. As with our preparation images, we need to begin with the distal neighbor of the preparation area and continue imaging to its mesial neighbor. Note that you should keep the bite registration to a minimum in this step. We need only enough of the opposing occlusal surface to cover the restoration area. With all images complete, click the green arrow Next button to continue. After calculating the models, InLab 3D will prompt you to verify parameters for this case. Click OK to enter the parameters menu. Make any revisions to the parameters as needed. Also, ensure that the checkbox for Design for Abutment Crown is checked if you intend to complete the entire abutment with the crown restoration in this case. Click OK to continue. We will now trim the model for this case. Trimming the model in InLab 3D is quick and easy. Simply click anywhere on or off the model and continue the trim line between the distal neighbor of the prepared tooth. This will create your virtual saw cuts. Single left-click to save your progress across the model and double-click to finalize the trim on the opposite side of the model. Repeat this step between the mesial neighbor and preparation tooth to finalize your virtual saw cuts. Click Next to continue. Verify the placement of your bite registration and click Next to bypass this step. We are now able to draw the margin of our gingival mask. This step will always use our manual margin finder tool to trace the line around the uppermost gingival area. Simply double left-click on the beginning of your margin line and proceed around the edge in short segments, saving your progress with single left clicks. Once you have circumnavigated the margin area and returned to your starting position, double left-click to finalize the margin line. Click Next to continue. It is now necessary to adjust your insertion axis. We must first verify that our model is oriented correctly on the screen with our distal label in the 9 o'clock position and the mesial label at the 3 o'clock position. Now adjust the model so the central fissure is parallel with the bottom of your computer screen. Also, ensure that you maintain even positioning between the mesial and distal neighbors of the prepared tooth. Once you are satisfied with the insertion axis, click Next to continue. Select the type of anatomy to fit this case from the selection menu. Choosing Individual will allow biogeneric technology to analyze surrounding teeth to calculate the best restoration for this case. Clicking Next will create the restoration for this case. The intuitive in-lab 3D software and biogeneric occlusion design the restoration based on the anatomy and contours of the adjacent teeth. Verify the accuracy of the proposed restoration by rolling the model. This is done by pressing and holding the left mouse button while moving the mouse across the screen. You may also turn on and off features such as the gingival mask and the antagonist. The red circle on the occlusal table of the crown designates the predetermined hole for the abutment screw. With the model and restoration verified, we will now use the Reduce toolbar to create the abutment and final crown for this case. Click the green next arrow to access the Reduced toolbar. Each click of the upper plus button will reduce the upcoming abutment by 1/10 of a millimeter. For this case, we will reduce by 0.8 millimeters in order to allow for more ceramic on the occlusal surface of the final abutment crown. Click the R within the Reduce toolbar to save your reduction settings. The orange color on the restoration denotes the area to be reduced. For this case, we have a full reduction. You can now see the abutment, along with the transparent final crown to be milled. Using the Design toolbar, you may now edit the abutment design using the Form or Drop tools, or simply select the green next arrow to move forward. For this case, we will use the Form tool to add material to the abutment on the buccal and lingual surfaces, and then smooth the area where the material was added. Click Next to view the milling preview for the custom abutment. Before you begin milling this component, we will need to begin the process of designing and milling the final abutment crown. We do this by selecting Abutment Crown from the Design menu. This will open up another window of the in-lab 3D software. Once the abutment crown has loaded successfully, you can begin milling both components of this restoration. Congratulations! You have now completed all necessary steps to scan, design, and mill a custom abutment and crown with in-lab 3D software. To get started with customized in-house ceramic abutments, contact your local Sirona or Patterson representative today.